I'm Emil. I am not a developer. Usually, when I go around talking on conferences, I have this screen here saying I'm not a developer because I'm not. My main work is with the human side of IT, management and stuff like that. So I usually say this, and I've been saying this for a couple of years. It's becoming less and less true. Like I have apps in the App Store now, so I can't really say that anymore. But I wasn't supposed to be a developer.
Where are you supposed to be?
I don't know. Marine biologist. I'm a professional diver. So if you want to go diving, I can go diving with you. So you can find me here. Twitter, Emil Oberg. GitHub, Emil Oberg. Monato.com is the company I work at. Usually I'm working with Liferay, which is a large Java enterprise platform, far from what I'm going to talk about today. However, I do have integrated what I'm going to talk about today with Liferay, and this is Ray, which is Liferay. Everything I'm going to talk about today is available on GitHub right now, actually. So both this presentation and what I think is going to be the finished code is available on GitHub. So you can actually step through it and check out the different steps of it. So yeah, that's it. So why are we here today? We're here to talk about web apps, mobile apps, and these are the 4 ways of creating mobile apps as I see it today. I might have missed some, or I might have. These are actually my name of the different technologies used to create apps on the phones or on the tablets. I'm going to talk briefly about those. This session is going to be first. I'm going to show you some slides, take a small break, and then we do some coding together. So these are the four ways of making stuff today. So first, native. By this I mean like really native, like actually writing the Java code for Android, or actually writing the Objective-C or Swift code for iOS, or writing I have no idea how you write Windows apps. C++? Anyone? C#? Only?
C++ also okay now.
All right. Anyone ever written anything for the Windows platform? Perfect. A little bit. All right. Native. All right. So not going to talk anything more about that. We're here to discuss JavaScript, right? But that's the first way. The second way is cross-compiled. So you write in one language, something magical happens, and there's an app at the end. I have no idea how this works. Xamarin is the biggest one. I might also be the only one. I'm not too sure. Like Xamarin on iOS OS does some kind of ahead of time compilation, create some libraries, some binaries, and on Android I think it's a little bit different. You can use C# to write your business logic, as I understand it, but you still have to write the views yourself for the individual platforms. If anyone has more idea of how this works, feel free to say so. I haven't managed. So that's the second way. Xamarin never got really like that big traction. And then we had the big way, the web-based way, using Cordova. Cordova is made by Apache and is the engine which powers PhoneGap. Many of you might know PhoneGap. Over time, PhoneGap became like its distribution of itself and contained additional tools, but so they may differ a little bit. But Apache and Cordova are the way to create web-based applications today. And by web-based, I actually mean that you are creating a web page. That's it. What you see in your device is a web page. So actually, you have a web view, a browser window without any Chrome, without any close buttons. And this makes it possible to write HTML, JavaScript, CSS. The devices actually have quite good browsers in them, much better than our normal clients have. They're pretty much up to date. And with that you can use all kind of web-based technologies or web-based frameworks. So you can use like Ionic or Supersonic, which are these big frameworks which are targeted towards developing mobile. But you can also use Angular as it is, or like Bootstrap for doing that kind of stuff. Or like jQuery or CanUI, which are UI libraries, or like really small libraries like underscore and stuff like that. But it's a web. It's HTML, it's CSS, it's JavaScript. No more, no less. That's it. It's good and it's bad. And then we had the fourth way, which is what I named the JavaScript runtime. And this works a little bit different. Here you write JavaScript code. That JavaScript code runs within a virtual machine on the actual device. And from that virtual machine, you translate and dispatch calls to the actual APIs of the devices. And then the devices do what they ask them to. Easiest way to describe this is like, say I want to have a tab bar. Tab bars are on every device today. Then I'm going to ask the device for a tab bar. I'm not going to say paint this element, which is 400 times 400 pixels. I want background black, and I want to do a drop shadow on it. I'm going to say, give me a tab bar, and the device gives me a tab bar, which makes like if I were to run this program on an older iOS device, it will show the black tab bar. On a newer one, it will show the white one, because tab bars have changed. I'm not painting a tab bar myself. I'm saying, give me a tab bar. And the same with Android or Android Lollipop. So the key part to remember here is there's no DOM. There's no HTML. There's no DOM. You can't do a div. You can't do a HTML button. You can't request give me a browser-based global property. Window. Thank you. Awesome. You can't use window. There's no window. And there's three suspects here. It's Accelerators Titanium, which has been around the block for quite some time. A couple of years now. Hasn't got that much traction. It's used in the wild. It has been used for a while. Facebook React Native, which is the buzzword on the street right now. And as I understand it, they released the the Android version like yesterday or something. And then we have Telerik NativeScript. All these three technologies are based on loosely the same thing. You have a virtual machine which are translating and dispatching Java calls to the API. So why wouldn't we run native things like, I'm talking JavaScript native things here? First of all, you won't get full code reuse. Like if you do a web-based app, which you put on the web, you might be able to put that in a PhoneGap wrapper and run it as is, pretty much. Some fixes here and there, but run it as is. You won't get that with doing this, because you can't reach that button element or that window property. Instead, I think this is React's way of saying it, learn once, write anywhere. What they're saying is we're using technologies we know. We're using JavaScript. And depending on how you do your business logic, you might be able to reuse some parts of it, or quite a big part of it, or not that much at all. I've been doing a web page and an app which pretty much do the same thing. I have been reusing like modules and stuff in between stuff I write, business logic. So that's the first thing. Second part, you have to learn new things, and we all hate that, right? And third part is it's still emerging technologies. They are used in the wild. They are used by real apps, but it's still emerging technologies. So why choose native? Well, first of all, it's performance. As you're not painting, you're not doing like an HTML page. You're actually saying, give me an API, give me a tab bar. They perform very, very well, much better than the HTML version. So that's the first. Second is look and feel. Instead of trying to mimic a whatever element, you get the actual element as it's supposed to look and feel. There's a couple of libraries which try to mimic like native device elements. Here you actually get them. That means that you get an iPhone experience on an iPhone and an Android experience on an Android, or Windows something experience. And the third is you can access the full device. You can get you can do everything with the device. You can get access to stuff like all the APIs, the cameras, the GPS, and stuff like that. PhoneGap does some of them. You can actually get access to the full device. And the reason to use NativeScript, as I say it, is, well, reuse skills. This is stuff I know. I know JavaScript. Here I actually say CSS. And that's a little bit strange since there's no HTML. NativeScript uses CSS as a subpart of CSS, a small part of CSS, as the language to style, because people know CSS. However, that gets translated to something else, something the phone understands. But I can reuse my skills. I can reuse my code, NPM modules, which I'm going to show you, third-party iOS or Android libraries, CocoaPods. Anyone know CocoaPods? CocoaPods is like it's like NPM for it's not really. It's it's a dependency manager for Swift and Objective-C. If you go to CocoaPods.org, you can search like tens of thousands of libraries, which you can integrate into your app if you want to. For Android, you can integrate like jar libraries. And most important of all, it's an easy API. And it's not just an easy API, it's a full and direct access API. And this is the core difference between Titanium and React and NativeScript. Where Titanium and React have these wrapper APIs. So like the Facebook guys and the Accelerator guys, they write the wrappers on real APIs. NativeScript do real API calls, meaning that if something is not implemented yet, like I want to change the color of the top bar or something. I want to change the color of that little battery bar. If that's not implemented in NativeScript, you can still write the code for it in JavaScript, which gets translated to Objective-C or Java and actually executed, which is quite awesome. That also means that a couple of hours ago I saw a GitHub repository with an app for the Apple TV iOS, I think is the name. Apple TV, the new Apple TV is going to have an app store. And you can write the app for that with Apple TV iOS, which is, I have no idea what the difference between iOS and Apple TV OS, but it's pretty much the same. So by changing two lines in the build script, you can actually build for Apple TV iOS as it's still the same OS. Same thing with the new watch, Apple Watch, or the Android Watch for that matter. Android Wear, I think it's called. Or when iOS 9 was released today, I think. Yeah, right. So you can use this on iOS 9 as you don't have to do any wrappers for it. You can access it yourself. It's always working. No problems. And lastly, open source. I like open source. And there's a lot of commenting going on. There's a lot of issues. There's a lot of traction in the community. I was checking. NativeScript 1.3 was released yesterday, and broke everything I did. No, not really, but it broke my build. And I think I had like 2 or 3 issues which was resolved in 1.3, which I reported and created. So they're really friendly and really open to for discussion. So this is what I'm talking about. Here's some code. you can actually do this. Like on Android, you can say var time equals new Android text format time. Then you can set it to 1st of January, and then you can write it to console. Or on iOS, if you want to add a alert pop-up message, you can say new UI alert view, add hello Uppsala.js, add an OK button, and show it on the screen. So this is valid NativeScript code. Write things which get translated to Java and Objective-C and ushered out. Yeah.
Does it work that it compiles the NativeScript into Objective-C?
No, it's not compiling. It's doing this in runtime. It's running in the VM, in the virtual machine. The virtual machine do the translation and the ushering to dispatching to the APIs. So this is not compiled at all.
What's the performance compared with like PhoneGap?
Better. I don't have any figures on it, but better, I would say. It all depends if you need it. Like you don't always need the like really big performance, do you? Depending on what you're doing. Yeah. I've seen performance benchmarks, but they have benchmarked against React as they're close together. But these are, of course, the VM makes it a little bit slower than native code. But I've never seen a performance problem at all. It's instant. You'll see soon.
How much about increase on size?
Like an Hello World app is like 3 megs. So like the runtime and those kind of things, I think it's like 3.5, 4 megs. And then it's just the size of your JavaScript files. So if you add NPM modules, obviously they can increase, but or add images or whatever, but code size 3.5 megs plus your own files.
So I have a question.
Mm?
So these two examples use Android and iOS specific things.
Hold on,
So
hold that question.
Yeah.
I'll show you next 2 slides and see if you have ones. Anyone want a sticker? Which one?
Sure.
No, all right. Come get it. Anyone else? All right. All right. So this is iOS specific. You can see here you can actually see here I'm targeting Android, an Android object. Here I'm saying new UI alert view. Anything in uppercase and like really long names are always iPhone. Or iOS. They name their things very, very long. It's like create an Hello World widget with and so on. So I can do this specific code. And how do I know to write this? Well, I can Google and I can read the documentation. This is the iOS documentation of creating a UI alert view, which is a pop-up. So you can see it's named UI alert view. It has the message property. It has the add button with tile button, and it has the method show. So I can see that and write the code. You might ask yourself, but why? Wasn't I supposed to not need to write Android and iOS code? And yeah, you're right. I'm just showing that you can do this. Module all the things. There's modules for everything, which acts as this broker between Android and Android iOS and the JavaScript code. These are regular modules, module exports. There's usually a file for iOS and a file for Android. So if I were to create a module in NativeScript, I would require the module, the dialogues module. I would create a dialogues alert, and then have a nice promised-based API, and show that and say dialogues closed. So we're going to see this later. There's a lot of modules. There's a lot of NativeScript provided modules for doing different kinds of widgets, like show me a button, show me a tab bar, show me an alert, those kind of things. And also for doing things like make an HTTP request, make something else, and so on. There's a lot of modules available on NPM, which are user contributed, and you can write them yourself.
type console log? Is it in the editor you have?
Actually, console.log is polyfilled, so yeah, you have console log. So I was a little bit lying saying that you don't have everything. You have console logs, you have set timeouts, those kind of things which aren't really in the part of JavaScript language. But you don't have a window. So I'm not going to code really yet, but soon. So to get started, what you need to do is you need to surf into NativeScript.org. They have this newly updated getting started guide, which is really easy to follow. The hardest thing when it comes to developing mobile apps is setting up the environment, especially the Android development, like CLIs, can be a hassle sometimes. If you want to develop iOS apps, you need to be on a Mac because you need to have Xcode. And Xcode is really easy to install because you press a button. But you surf into nativescript.org and see the guide, and you see that it says npm install NativeScript. That's pretty much what you need to do, apart from installing like JDKs and actually changed yesterday. It's using Gradle now, which made a performance increase of like, I think it's like 5 times less for building in the project with Gradle than with Ant. And the Android SDK and those kind of things. With Xcode, you press a button to install Xcode. That's it for the this part of the tutorial.